So let us start with a short recapitulation of two coins which are distinguishable. Okay, so when two coins are distinguishable, when we consider one to be silver and gold, with the heads as A1 for silver and A2 for gold, and tails as B1 for silver and B2 for gold, then when we toss a coin, it is either heads, two heads, head and tail, tail and head, tail and tail, isn't it? So this is how the two coins would behave like, and the total number of ways, therefore, if you take it, it is A1 A2, A1 B2, B1 A2 and B1 B2, which algebraically you can write it in this manner: A1 plus B1 into A2 plus B2, isn't it? So you see, actually then the total number of ways, if you look into the total number of ways that we had seen yesterday, is equal to 4, isn't it? So the favorable ways for any one event to occur will be equal to 1, isn't it? And therefore the probability of any one event to happen will be 1/4. So this was what we had observed. So the probability is 1/4 for A1 A2, 1/4 for B1 A1 B2, 1/4 for B1 A2 and 1/4 for B1 B2. The total probability being 1. Now what will happen if the coins are indistinguishable? So when the coins are indistinguishable, you see, well, this is how the things would look like. When the coins are indistinguishable, then, well, in that case then A1 equal to A2 equal to A, and for 1, and B1 equal to B2 equal to B. That means now you are using, instead of two different coins, now you are using same kind of coin, say only gold coin. So now the heads will look the same, the tail will look the same. So the typical expression of A1 plus B1 into A2 plus B2 would be equal to what? A plus B into A plus B, isn't it? And that will be equal to, see, this will be equal to A plus B whole square. Now what is A plus B whole square? As all of you know, it is equal to A square plus twice AB plus B square. So A square plus twice AB plus B square, that is the probability of getting the head of one up. The head of one up and the tail of second up is actually 2 times 1/4 now. Instead of 1/4, 1/4, 1/4. Probability of this is 1/4, this is 1/4. But now this has become AB plus AB. So the probability of the head of one up and the tail of one up is 2 times 1/4. So we can write that the probability of the head of one up and the tail of second up and the tail of second up is equal to 2 into 1/4, which is equal to half. Okay, all right. So you see, in other words, you can say that the weight of this event, the weight of this event is half. You can say that the weight of this event is the weight of this event is 2 times the weight of the other events. Okay, so if you show it in tabular form now, if you try to show this in tabular form, suppose say you make a table. say you call this number, okay, and then you say event. All right, then suppose you use a symbol, then you talk of weight, okay, and then if you talk of probability, all right, if you talk of probability, suppose say this is probability, all right. So if number is say 1, heads of 2 face up, what do you get? A, which is equal to A square. Weight is 1. Probability is 1/4. Table second one, head of one and tail of the other up. Okay, head of one and tail of the other up. What do you get? AB. AB, AB. What is the weight of this? 2. So what is the probability of this? We have seen just now, it is half, isn't it? And then number 3, what do we get? Tail of 2 face up, isn't it? So tail of 2 face up. What do we get over here? B, which is B square. So what is the weight factor for this? 1. What is the probability? 1/4. Okay, so if you try the same, suppose say you try the same for 3 coins which are indistinguishable. So suppose we try this tossing for 3 indistinguishable coins. Okay, so basically we do it for three coins which are indistinguishable. How will we do it? Let's see. So three coins which are indistinguishable, if this is the case. Same table if we do, suppose say this is the number, okay, then we write events, then we write symbols, and finally probability. Okay, so if we do the same table, what do we get? Heads of 3 face up. We start like that. Say number 1. Heads of 3 faces up. What will be the symbol? A1, A2. So initially if I consider this not to be indistinguishable, suppose say I consider this to be indistinguishable. Distinguishable means A1, A2, A3 are your 3 coins: gold, silver, copper. So 3 faces up, A1, A2, A3. What is the probability over here? Half into half into half. Independently the event is occurring, so probability is getting multiplied. It is 1/8. Okay, head of first and second and tail of the third up. Okay, so this is number 2. Head of first and second, okay, and the tail of the third up. Suppose if I do it like this, A1, A2, B3. Okay, probability is 1/8. Number 3, well, head of first head of first and third and tail of second up. head of first and third and tail of second up. This is again equal to 1/8. Number 4, what will we get? Suppose say the head of second and third up. Head of second, this is A2, and third up, and the tail of first up. This is also 1/8. Okay. So then what will we get? We'll get say A1, B2, B3. This is 1/8, isn't it? Then what will we get? The head of the second and the tail of the first and third. Tail of the first and third and head of the second, isn't it? This is also 1/8. So this is 5. This is 6. Then what will we get? 7. What will we get over here? You see, we'll get for 7, what will we get? See, we can take then, well, the tail of first and second, tail of first and second, and the head of the third up. This is 1/8. And then number 8, what do we get? Well, the tail of all three up, B1, B2, B3. So this is also 1/8, isn't it? So, well, so when coins are distinguishable, this is what we get. The probability when we are tossing 3 coins. Just imagine what happens when the coins are, now let the coins be indistinguishable. Let it be indistinguishable. Okay, let the coins be indistinguishable. What will happen then? A1 equal to A2 equal to A3 equal to A, isn't it? And B1 equal to B2 equal to B3 equal to B. Okay, all right. So you see, that is it. So you see, therefore, what happens? Now, therefore, what do you get? A plus B into A plus B into A plus B for 3 coins, which is equal to A plus B whole cube, isn't it? And that is equal to, what is that equal to? A cube plus 3A square B plus 3AB square plus B cube. Alright, so the probability of getting heads of 2 and tails of 1 upwards, or tails of 2 and heads of 1 upward, that means heads of 2 and tail of 1 upward, and the tail of 2 and head for 1 upward is 3 times 1/8. So now here the probability of this is 1/8. For this one it is 1/8. It is 3 times 1/8. This is also equal to 3 times 1/8, and this is 1/8. So this is 1/8. This is 3 times 1/8. This is 3 times 1/8, and this is 1/8. Okay, all right. So that's what, if you do it in tabular form, you have to write it there. So now, if you have n indistinguishable coins, so now if we go for n indistinguishable coins, then what do we get? We write this as, you see, we write it as a plus b whole to the power of n. Okay, and this, if you expand, you know this goes as a to the power n plus, which is nc0 a to the power n, plus nc1 a to the power n minus 1 b, plus nc2 a to the power n minus 2 b square, plus like that ncn b to the power of n, isn't it? So this, if you generalize, what can you write this as equal to? This will be equal to summation n c r a to the power r b to the power n minus r. Okay, so r will be equal to 0 to n. So r goes from 0 to n. All right. Okay. So, well, what do you get over here as a result? You see, what you get is the following. This is equal to, well, so this is what you'll be getting if you make a summation. Now, what is the total number of terms representing the possible combination? Total possible combination, that means the weight factor if you try to find out. So this plus this plus this plus whatever you have, the weight factor, sum of the weight factors. So that we call the total number of terms. The total number of terms for all combinations, the total number of terms will be summation of NCR, summation of this factor, isn't it? This summation goes from r equal to 0 to n, and all of you know, if you do it, you have learnt it in your school, this is 2 to the power n. So you please do it. Do this, because you learnt it in your school, okay? So please do it and find out whether it is equal to NCR is equal to 2 to the power of n. So, well, what would be the probability of your combinations? So let us find out the probability of the combinations, okay? So the probability will be equal to what? NCR for every weight factor. That's how we found out the probability. If you remember, when we tried to find out the probability, it is 1/8. That means weight factor 1 divided by the total probability. Then it was 3/8. See, it was 3/8. That means 3 is the weight factor here divided by the total probability. So now if I try to find out the probability, see, then if I just try to write down the probability of the combination or state, then how do we get it? This is equal to NCR. All right, so let's NCR divided by 2 to the power of n, because that's the total. So this is actually your probability for you signify this as P r n minus r. This is your probability. Okay, so what is this actually equal to? Factorial n factorial r factorial n minus r 1 by 2 to the power of n. This was what you have been asked to find out. Okay, how do you get the maximum probability? Because the maximum probability gives you the most probable state. The maximum probability. How do you get it? This actually corresponds to the most, you understand, isn't it? A state will be most probable when you consider the maximum probability. Okay, so this gives you the most probable state. This, well, you can show that this occurs when r is equal to n by 2. If you just differentiate p with respect to r and do some of mathematical formulations, you can show that this happens at r equal to n by 2. So and also that means when n is even, and when n is odd, for n even, and r is equal to, well, n minus 1 by 2, n plus 1 by 2, okay, and n plus 1 by 2, n minus 1 by 2. If you take this combination, these are the two for n odd. For n odd, under these two conditions, okay, these two will be same. For n even, there is, this is one probability that you will be getting, and there is only one, and for n odd you will be getting either this, you can take this as your combination or this as your combination, but both of them will have the same probability. Thus there are, so because they'll have the same probability, you'll get one for both. So one for this, one for this, so there will be two most probable cases. If n is even, you'll get one case. For n odd, you'll get the other case. Okay, so the most probable value then, if you put r equal to n by 2, then P max, you can show this as equal to, well, see, this was your expression for P, factorial n, factorial r, factorial n minus r, 1 by 2 to the power of n. So P max, you get maximum for r equal to n by 2. So what you can write over here for r, n by 2, this also n by 2. So what you get, factorial n by 2, factorial n by 2, 1 by 2 to the power n, or if you put this combination for r, either n minus 1 by 2 or n plus 1 by 2. Okay, so then you get the combinations for P max. For odd only I am writing n by 2, n by 2, 1 by 2 to the power of n. This is the most probable state. Now can you tell me what you will be getting for the least probable state? If this is P max, what is your P mean? How do you get the minimum? Obviously, when do you get your minimum? When r is equal to 0 and when r is equal to n. P minimum is obtained when r is equal to 0 or r equal to n. Okay, and you can see by substituting this value that it is just 1 by 2 to the power of n. So in a probabilistic distribution where you have particles of large numbers, and when you are doing work on that, which one is the most probable state will define the property of that system. Okay, the most probable state will dominate and characterize the property of the system. The least probable state will not be so dominant, though existing but not dominant. Okay, so this gives you a very preliminary idea using statistical physics principles of obtaining the principles of probability, basically of obtaining the most probable state and least probable state.